We've considered exponential growth functions, and now let us consider exponential decay functions. And so if we go back to this, let's see, y equals ab squared, well, excuse me, not squared, ab raised to the power of x minus h plus k, our general form. We have exponential decay when b, the base, is greater than 0 but less than 1. And we can see that here in this first function we're going to look at, where we got -3 times 2/5, 2 over 5, raised to the power of x minus 4 plus 2. Now, before we go to the calculator and actually graph this, let's think about what kind of transformations are happening. One, I see I got a horizontal shift here. And I've got a horizontal shift to the right by 4 units. And I'm going to have a vertical shift, or a vertical translation, up the y-axis by 2. This negative in front of this 3 tells me that we're going to reflect over, we're going to flip over the x-axis, and then 3 itself is going to stretch this function vertically. All right, now let's go ahead and then analyze this second function, and we'll go graph them both. So one, I've got a base less than 1, greater than 0, -5/6. We've got a horizontal translation. It's going to go to the right along the x-axis by 1 unit. We've got a vertical translation. Vertical shift is going to be up the y-axis by 1. And then a is 3/8. So it is greater than 0, less than 1. Absolute value of it greater than 0. And it's going to compress the function vertically. And so that's what I expect to see just by looking at the function equation itself. And you need to train yourselves to be able to look at the function itself and begin to start to predict what's going to happen. Now, in addition to that, we're going to state the domain and the range. We could do that right now. Let's see, I think the domain is going to be all real numbers for both functions. In this top function, our range is going to be such that y is greater than 2. No, excuse me, it's going to be less than 2. Less than 2 because of the flip. The flip is going to make that less than 2. And then in my bottom function, again, the domain should be all real numbers, but then we should see with that upward move on that vertical shift that y such that y is greater than 1. All right, let's move to the calculator and see what we got. All right, so here we are. Of course, I want to check my window settings. I see I'm kind of at the default -10, 10, -10, 10 scales of 1 for both x and y. That looks pretty good. And maybe I want to check my stat plot, make sure it's off. Yeah, it's off. All right, so we're just going to go to y equal, and we're going to graph this first function, which was -3. And then I'm going to put in parentheses the 2 over 5, because that's what we are raising the power of. That's our base, raised to the power of x minus 4. I may have had x minus 1 on that previous slide. I don't recall, but we're going to do a -4, which is going to move it 4 units to the right, and then plus 2. And I think I'm going to go ahead and graph the just the base raised to power of x, so we can kind of evaluate some of the differences. I'm going to do that in y2. So I got 2/5, 2 over 5, raised to the power of x. Let's go look at our graph, see what we got. All right, so here comes one with my transformation. All right, so the red is my parent, and I can see that in the blue, it's flipped over the x-axis. It has moved up 2. So right here, when y is 2, I see I got a horizontal asymptote right about there. And we have moved 4 units, 1, 2, 3, 4 units to the right. Now, what about our domain? Well, our domain is still all real numbers as we're coming from the left-hand side. Obviously, as far as end behavior is concerned, another element of analyzing functions, we're going to negative infinity. And as we're going out here to positive infinity, y is equal to 2. We got a horizontal asymptote there on our on our transform function, and our range is y such that y is less than 2. So any value from 2 down to negative infinity is within our range. Now let's go do the other two and we'll be done looking at this. All right, so our second function didn't have a negative on it. It was just, what was it? It was 3/8. I'm going to put that in parentheses too. 3 divided by 8. Keep hitting things. Delete. 8 parentheses. My mouse is kind of sensitive. Parentheses again for the 5/6. The base that we're going to be raising to a certain power, which is raised to the power of x minus 1, should give us a horizontal translation to the right by 1, and then plus 1. And let's go ahead and change the base of this function in y2 because we can kind of compare the two together. I always like to do that, so I can get some kind of comparison, and I'm just going to put 5/6. Again, I put it in parentheses, raised to the power of just x. And that's going to show up in red. Let's go take a look at our graphs. So here comes our blue. Now I can see how it's been compressed. Think about how it's been pushed down. It's been pushed down. That blue has been pushed down versus the red. What else do we see? I see that we're up 1. We've been transformed up 1 on our y-axis, a vertical shift of that, and we've got a horizontal shift of to the right by 1. What about our domain? Well, our domain is still all real numbers. And if you look out here on the left end, I can see that y is going out here to infinity. And I'm looking at the blue, we're going out here to infinity, and we have a horizontal asymptote where y is equal to 1, but everything's going to be greater than 1, so y such that y is greater than 1. Exponential decay functions, where our base is between 0 and 1, greater than 0 but less than 1, raised to a power.